The building enclosure is designed to manage heat flow, which is defined by three modes of heat transfer. First, radiation. Radiant heat primarily enters the building enclosure through windows and the roof. Radiant barriers reflect radiant heat. Examples include low E windows and reflective insulating materials in the attic. Second, convection. Convective heat transfer is driven by air through openings in the building enclosure. The convection can be both natural, such as hot air rising in a stack effect, or forced air by equipment such as a fan. Air barriers manage heat flow by minimizing air infiltration through the building enclosure. This is accomplished by using tape, caulk, foam, and other air barrier materials to create a continuous air barrier system. Third, conduction. Conductive heat transfer occurs when heat goes through the building enclosure components from a hot environment into a cold environment. Materials with a low thermal conductivity manage heat flow by minimizing thermal conduction through building enclosure components. This is accomplished by using insulating materials such as fiberglass, cellulose, and foam in the exterior walls, attics, and basements or crawl spaces. To ensure good thermal resistance performance of fiberglass batt insulation, it is important to avoid compression, voids, and gaps during the installation. More generally, it is important to minimize thermal bridging, which provides a path for heat flow across the building enclosure through a material with low thermal resistance. This can be significant even when the area of the low-R material is small. For example, wood framing has much lower thermal resistance than insulation materials. It is therefore important to avoid overframing the exterior walls. The management of heat flow is important to the overall performance of the building enclosure.